we're going to be looking at parallelograms today. We're going to come up with what the different properties of parallelograms are. Vocabulary, what is a parallelogram? What's it sound like? Probably the definition involves. Where did it get its name? Parallelogram. Edie, what do you think? Okay, probably has something to do with parallels. Yeah, how many parallels and how many sides total? Okay, it is 4 sides, and can help because on graph paper, what do we know? How would we create parallel lines using graph paper?
They're straight. They're cross.
Oh, they're going to be straight, and what else? To make lines parallel, they have to have the same slope. Okay. So I would use the intersection points on the graph paper as reference, but draw yourself half of a parallelogram. In other words, draw an angle. I don't really care what position you put it on. I would just use corners of the graph paper to help you line things up. So draw half of a parallelogram. And then draw the other half. And I guess you don't have to have graph paper. Or you don't have to have an XY axis. You can make it horizontal. Let's not make both horizontal and vertical. So don't try and make a rectangle or a square. Let's try and not have those angles be 90. Otherwise, it's going to have things about it that we don't know. But make these corner points on intersections on the graph. Otherwise, it might not be perfectly a parallelogram. So then, since I went horizontal, I know my top edge is going to be horizontal. I'm going to count my slope to make sure the slants are the same. So if you've made both of them slanted, count the slope, like what's your rise and run. And go from one end of your segment to the other end of it. What's your rise and run? Because you've got to count that same amount to get the other side of your parallelogram created. So make the same slopes. Okay, 1 or 2 angles. What should all 4 angles total? Should be the interior sum. Is that n minus 2 times 180? So 360 is what the angles inside should total. So you can tell partially whether you're coming up with the right result. What are some other things that might enter into verifying some angle measures? We did things with parallel lines. That's exactly right. If these were 45, that would work out. So that's a little error in the measuring. Okay, since we have parallel lines, like AD and BC on my picture up here are parallel, so you can think of the AB as a transversal. So what kind of angles would angle A and angle B be called? Parallel lines and a transversal. Can you picture that? Yeah, they're same side interior angles. Now that's the one out of that set of theorems that a lot of you haven't figured out that it's different. What's the relationship between this angle and this angle? They can't be the same. They're not congruent because isn't one acute and the other's obtuse on my picture? So it's not that they're congruent, what's their relationship? Can you tell by the numbers in what you just did?
The support.
Supplementary? They add up to 180? Correct. Let me show the angles here. Sometimes it works up here, sometimes it doesn't. It's a day that it doesn't want to. Okay, so show the angles. Mine are in decimal, but add up to 180. Notice that not just those, but when I go this way, angles B and C add up to 180, C and D add up to 180, D and A add up to 180. So we do have a lot of supplements going on. Why is that? Because they're same side interior angles. So that should make sense. That maybe isn't anything new, it's just applying something we did earlier to this. What else do you notice about angles besides those consecutive ones have to add up to 180? Looks like my angle B and angle D, no matter where I stop it, the opposite angles there are the same. How about in your picture? Opposite angles are the same? Okay, correct. So opposite angles the same, consecutive angles are supplements. All right, let's try something else. How about side lengths? Measure how long your sides are on your parallelogram. You can choose either metric or inches. I think the millimeters is probably more exact and a little easier to write down. Measure all four sides. All the same. Okay. Are anyone getting all of the sides the same? Okay, so evidently some are the same. Which ones are the same? How would you describe it? Exactly. The ones across from each other, the opposite sides. Okay, opposite sides, and if you look at my numbers up here, when I change it, what I use to make this is that GeoGebra. So yes, opposite sides are going to be congruent, no matter which way you flip it. Okay, how about diagonals? Draw your diagonals in. It's a diagonal. Connect opposite vertices. So connect like A to C. Hold the ruler there, Kelsey. So what are some things we might check to see? As you draw that, are you wondering anything special about that diagonal? like a kite. Some kites are weirder than others. So what do you want to investigate? What should we measure? Wondering anything? Or just waiting for me to tell you something? Come on, what's your mind curious about? Are they perpendicular? When they intersect at the middle there, the 90-degree angles?
Nope.
Evidently some don't look like they are. A few of them, as I'm looking around, look like maybe they are. If you don't think they're perpendicular, let me bring up my numbers and see if I agree with you. Show the diagonal angles. Okay, so at that center point, yep, they're not. I probably could move it so that they are 90s, but a lot of them are not. Okay, what else? Zach?
All I know is that the vertical angles are the same.
Okay,
Yeah.
vertical angles are the same. So something we've studied that we can apply here, right? But they're not necessarily 90. Are the corners bisected? I don't know if you had time, we didn't talk about measuring that, but I've got my measurements up here. 33, 10.7, obviously that's not bisecting the corner. See anything there? You see alternate interior angles like the 17.4, 17.4, 33, 33, yep. We've got the parallels, so we have those alternate interior angles. Look at the triangles. Let's see, 33. I guess I was thinking maybe the triangles were isosceles, but no, it doesn't look like it. I don't know that I'm coming up with too much there. How about lengths? What do you think? I'm not going to click it yet. Diagonal lengths. If I measure how long the diagonals are they going to be the same?
Two of them are going to be the same. That's my guess. Like AC is probably going to be, AG will probably be congruent to GC.
You think AG and GC will be the same? Would you think the same on the other one? BG and DG, maybe the same? Do you think the total AC is going to be the same as the total BD? The whole diagonals? Some of you are saying yes, some no. Okay, on yours, before I just show you numbers, on yours, measure the whole diagonal. What's the length of one whole diagonal and then the other whole diagonal? The whole diagonals, are they the same? Okay. Jake, did you measure yours?
Yeah.
Are they the same? No, they shouldn't be. Now, I've got two things showing here. These are the little measurements. So Connor was thinking these two would be the same. They are. And the other two are the same. But when you total, the total of AC and the total of BD, they are not the same. And you can make parallelograms where they're almost the same. And you can make them where they're definitely different. One diagonal is a lot more than the other. So this chapter is one that if you forget something, you can probably create a figure and take a look at it and think, okay, now were the diagonals congruent in a parallelogram? If you really overemphasize the parallelogram, you can definitely say, no, that's a lot shorter than the other diagonal. So you can come up with some of the things. All right, let's take a look at our theorems and see if we've discovered everything that we were supposed to. Let's take a look at your notes now. Okay, did we come up with the first one? If a quadrilateral is a parallelogram, then its opposite sides are congruent? I believe we did. Yes. A parallelogram. And the conclusion, how do I know A and C are opposite angles without seeing the picture? Look at the order that the points are listed in the name. Remember, this goes consecutively around the shape. So A and C would end up across from each other. B and D would be across from each other. Those are the opposite angles that are congruent. (623). If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So again, parallelogram, A, B, C, D, so that we can explain the conclusion. Everything filled in? And remember, parallelogram has how many sides? 4. And where did it get its name? What's the definition? 2 pair of parallel sides. So in other words, the opposite sides have to be parallel. That's the definition. Okay, let's try some problems. What's this symbol mean? Parallelogram. It's not just a 4-sided figure, it is a parallelogram. CDEF gives you some measurements. Find CF and figure out what theorem or definition is being used. So what is the length of CF and why? How long's CF? Jacob? Yes? 74, and why? Okay, the opposite sides theorem, correct. Opposite sides are congruent. Same information, but this time I want you to find angle EFC. And give the support. EFC is this whole angle. Let's see what other angles are given. Got some ideas? Not yet? What angle do we know? FCD. FCD. This whole angle is 42 degrees. This would be the next angle around the parallelogram. So what's that parallelogram consecutive angles theorem say? Consecutive angles are supplementary. So if that whole corner is 42, this whole corner would be 180 minus 42, 138. And that was the theorem about the consecutive angles being supplementary. Now, is this 42 getting cut in half? Was it bisected, 42 and 42? Or I mean 21 and 21? No, this one kind of looks like maybe it is, but when I look at the 138, that definitely looks more like almost a 90 and a something else. So on a parallelogram, it is not bisected at the corners. It's just the total. Okay, what's DF's length? And notice DF is a diagonal. Are the diagonals the same length? No, so it doesn't matter what CE is. It wasn't even given. So how are we finding DF? Right, it says DG is 31. So 31 times 2. So the answer should be? 62 millimeters. And what's our support? Okay, parallelogram diagonal bisector theorem. Correct, that one makes sense? Okay. Now we switch to a basketball support. You should grab your marker board, the manual marker board. Answer this one and give the support, that way I can see that everybody's thinking. You're supposed to find and KN. And give the support. Some are showing me as they're going along. That one was 28 inches, and it was the opposite sides theorem about angle NML. Those that haven't shown me yet, look at which angles you're looking for and you're given. 106. It should be 74 degrees. You were given LKN. You were given this one as 74, and you are trying to find NML, this one. So you're trying to come up with the opposite angle, not the consecutive angles. So that was opposite angles theorem, 74 degrees. And same picture. Find LO. Give the support. Give me the support. Like what theorem or definition are we using? Which I haven't seen. Alright, that one should have been 13, and it was the theorem about a parallelogram diagonals of bisect. Alright, a little bit more algebra. If you feel like this would be one you want in your notes, it should be 7, and substitute back. Alright, the work on this one, you set the 6a plus 10 and the 8a minus 4 equal to each other. A is 7, and then substituting back in, 8 times 7 minus 4 should be 52. Question? So we were using the fact that opposite sides have to be congruent. All right, how about finding measure of angle Z in that same picture? Angle Z. Okay, what's the angle calculate to be? 65? You set it up right or not?
Yeah, I did.
Yeah. Okay, question on that one? Okay, how about one that looks a little different? Find JG. JG is W plus 8. Parallelogram, diagonals that bisect. All right, let me skip ahead to, I think there's a proof on here. Oh, well, I know, there's this one. Okay, on the back side of your marker boards, there's a graph. Okay, I'm giving you 3 vertices of the parallelogram. I want you to find the other one. So think what we did to make a parallelogram on graph paper earlier. We were counting slope. That can help you. And you also need to pay attention to the order that the name is, because that will tell you, like in general, where to connect. So J was 3, -8. K was -2, 2. And label what's J, what's K. You're going to need to know which one is which. And then L was 2, 6. And let's connect what we can. It said the parallelogram was J, K, L, M. So connect J to K, K to L, L to M, but we don't know where M is. But does that give you a bit of an idea? So count your slope. So your picture is kind of like this so far, right? Okay, so from K to L, you have to go up, what is it? Up 4 to the right 4. So from J to get to M, you have to go up 4 and to the right 4. So count that same up and over. That point should be where M is to make the parallelogram. Keeping in mind it was called, let me back up here. It was called JKLM. So I knew that the parallelogram would go from J to K and then to L. M needs to be somewhere over here in order to connect back. Now you can count slope on whichever sides you want, but to figure out from J up and over, it has to be the same as K. So go up and over the correct amount, do the same down here to locate where M was. Does that make sense? I've got a second one. You want me to do a second one of that? Okay, if not, we'll click ahead to a proof. And I was just verifying. So did you get the point 7, -4, that last one? Counting the slope is a key to those problems. On this one, look at the directions. This one's a little bit more tricky. It's PQRS. So if I connect PQ, where's R? R has to come before S. So it would have to be up here somewhere. In order to make PQRS as a parallelogram. So make sure you notice what order the points are. So I counted up and over, and they got point R to be up there. All right, and a proof to look at. You might want to put a proof in your notes. All that we're given is that it's a parallelogram. That's all. We're supposed to prove triangle AEB, the one on the left. We're supposed to get this triangle congruent to this triangle. But you've got a page of a definition and 4 theorems that if you know something's a parallelogram, things that you can come up with. How do we get triangles congruent?
Those postulates and theorems, like the ASA.
Okay, like angle, side, side, those things. So on the 2 triangles that I have dots in, can you come up with any angles or sides congruent and support for it? There's many ways to do this proof. So get me started with something.
BEA.
BEA. This angle?
Angle, yeah. Is congruent to CED.
Why?
vertical, maybe
Okay, vertical angle theorem?
yeah.
Okay, that would be okay for one. If you're writing each line, your given should probably get in there first. So line one,
Well,
given the triangle, or that's a parallelogram. Then what Grant said was angle BEA is congruent to angle CED. Vertical angle theorem is what he's supporting that with. Okay, line three, what's something else you can come up with? BE and ED are congruent. What support do you have, Michael? Okay, so that one about if it's a parallelogram, diagonals bisect. 624 if you're doing it by number.
So AE is congruent to CE.
AE congruent to CE.
Same theorem.
Same theorem about the diagonals bisecting.
So they're congruent.
Yeah, right now we're done, aren't we? So the last line, triangle AEB congruent with triangle CED by
Side angle.
side angle side. What are some other things we could have done? We could have done the opposite sides being congruent and maybe not even any angles. We could have done some alternate interior angles. We probably have to state the parallels first, but we can get there because we know it's a parallelogram. So we did one of the easier methods on there, I think. So there are some proofs, but I personally don't think they're too complicated. Here are the ones that I want you to work on. Page 395. 1 through 13, 26, 32 to 44, a 46, and a 47 for some review. And you have a short week this week. So tomorrow we'll get our state review in and we'll do lesson 6.4. We're going to skip 6.3 tomorrow. But then on Wednesday we'll have a quiz over those first three sections. What we did Friday, what we did today, and what we do tomorrow. On Wednesday we'll do lessons 6.3 and 6.5 together. Then you have a break. Those lessons, and you do have a quiz on Wednesday before you take a few days off. And this chapter will end next week. I have Thursday as probably the test for this chapter.
Sarah
So you can
versus
leave the
Song.
markers and the erase thing underneath your desk with that board, but as far as like the protractor, compass, packet, drop those off under the table.